Hello students, welcome to our online classes for 6th grade arithmetic work text classes. Today we're going to talk about factorization. Prime and composite numbers. Prime and composite numbers are factors that also natural numbers. Natural numbers are the ones that we count. 1, 2, 3, 4, 5, etc. So these natural numbers help us to find numbers that are greater than 1 or either prime or composite numbers. So what's a prime number? A prime number is a number that has only two factors, 1 and itself. That means that the number has only two divisors, 1 and itself. Example, the only way to multiply up to a prime number is 1 times the number itself. Example, 3 is a prime number, is it? Yes, it is. Well, what numbers can be multiplied together to give me 3? Let's find out. The numbers that can give me 3 are 1 times 3 or 3 times 1. And that's it. No other way to multiply up to 3. That means that it's a prime only number. You can also find a prime number when you make a division. When you divide 3 by 1 or 3 by 3. Then you can see it that no other number can work and have a whole number in the quotient. Example, if we divide 3 by 2, then we're going to have a remainder of 1. That means that we won't have a prime number. So factors are only 2, 1 and 3 in this case. So 3 is a prime number as an example. Multiplication or division help us to find prime numbers. It's your choice to use multiplication or division. Always write down your math thinking. We begin with factoring. Factoring is a mathematical operation to find out the number of factors that we have in any given number. Why studying factor is very important? It's very important for us to learn how fractions are going to work. Fractions use a lot of factors. For instance, we have this multiplication table in which we can see the factor 24. 24 is a number that could be obtained by multiplying 4 times 6, which gives you 24. Or also multiplying 6 times 4. So these are the factors that give us the answer of a multiplication or also a division. We can also see that 24 is a factor that could be found with a multiplication of 8 times 3, or 3 times 8 is going to give us the factor of 24. So that means that we can have many ways of getting the factor depending on the numbers that we are multiplying. As we can say, the 24 as a factor could be given in these two ways, 4 times 6 or 3 times 8. Both are right because the answer is going to be 24. That means that we have to find all the factors that we are need to get a number. So as long as we find these factors, we're going to do the factoring. Well, to find factors of any number, it's important for us to run a divisibility test. A divisibility test gives us the factors that we need to find depending on numbers. Like 24, for instance. 24, if it's divided by 2, it's going to give us 12. Or if it's divided by 1, it's going to give us 24 too. Also, 12 could be divided by 3, could be divided by 4, could be divided by 6. However, 24 can also be divided by 8. That means that we have found all the factors that could be used for 24. In this chart, we can find easily which are the numbers that are factors of 24. We have to run the numbers from 1 to 12, since the 24 could be divided by 2, is going to give us 12. So the factors are 3, 4, 6, and 8. 7 is not a factor of 24, because if we divide 24 by 7, we're not going to get a whole number. The same thing, if we divide by 24 by 9, we're not going to get a whole number. And of course, these other numbers are not going to give us whole numbers. They will always give us decimals. We can see in the example that 2 can also be a factor of 24, because if we divide 24 by 2, we're going to get a quotient of 12 as a whole number with no decimal number. Yes. As we can see in this chart, we can show the factors that are going to give us the factor that divides 24 by 2. It's going to be 12 and 2. And all the circles are giving us the factors. Now let's check with 5. If we divide 24 by 5, as you can see in this calculator, we're going to get a different answer. Like you can see, 4.8 is not a whole number. That means that 5 is not going to be a factor for 24. Next, we're going to try a number 9 divided by 24. Let's see what the answer is going to be. Oh, there we have. The answer is 2.666, which is a decimal number. That means also that 9 is not going to be a factor of 20. How about 10? If we divide 24 by 10, are we going to have a whole number? Maybe not. Let's see it. There we go. But the answer we have is 2.4. 2.4 is a decimal number. That means that 10 is not a factor of 12 either. Finally, to complete this chart, we are going to divide 24 by 11 as the last factor and see what the answer is going to be. Oh, you can see it now that 2.18 is the answer, which is not a whole number. That means that 11 is not a factor of 24. Well, this is an example how to run a test, a divisibility test, to find the factors of a given number. In this chart, you can see that we tested with 1, with 2, 3, and 4, 5, 6, 7, 8, 9, 10, 11, and 12. But the only factors that divide 24 with the whole numbers are 1, 2, 3, 4, 6, 8, 12, and 24. 5, 7, 9, 10, and 11 are not going to be composite factors. That would be, like in this case, are not going to be the factors that we need to find for 24. Now we are going to talk about prime factorization. Prime, as you know, it would mean that's like a cousin. Cousin is like a relative of a person which is not very close to a person. So it's kind of a special person. Let's see what prime factorization is about. In this case, we can show what a prime number is. A prime number is a number that could be divided the same number by 1 or also multiply by 1 or by itself. In this case, 7 divided by 1 is going to give us 7. The same way, 7 times 1 is going to give us 7. But you can see here, 7 divided by 2 is going to give us 3.5, and so on. These factors can show us that these numbers are not composite numbers because they are decimals. The only one that's going to give us a prime number, the prime only number, is 1 and itself. Alright, as I told you before, a prime number is a number that could be divided by 1 or by itself. The list of prime numbers that we have, the numbers that are between 1 and 20, are as follows. 2 is the only prime even number. 3, 5, 7, 11, 13, 17, and 19. These numbers can only be multiplied by 1 or by itself, or divided by itself. Alright, it's important to know the difference between what is a prime number and what's a composite number. A prime number, as I told you, is a number that could be divided by itself or by 1. 1, by many technical reasons, is only one number prime that could also be a composite. But for practical reasons, what we have to say is that composite numbers are numbers that could be used and divided in the factors that give us the same number. For instance, 4 is going to be equals to multiply times 2 times 2. 6, 2 times 3, 8, 2 times 2 times 2, 9, and so on. As you can see, these are composite numbers that have these factors that give us the right number. Well, it could be a very tedious and hard work to find the factors of any given number. To help us, we have the method of the factoring tree. A factoring tree is a method in which, when you have a number that you know that it has 2 factors, it starts to divide it in 2 branches, for instance, and maybe the other one has 2 other branches, until we get to the last prime number. And then we're going to have 3 factors which multiplied are going to give us the original number. This is called a factor tree. An example like this is as follows. As an example of a factor tree, if we have this number 12 that we have to divide in its main prime factors, we do the prime factoring saying 12 could be a multiplication of 2 times 6. 2 times 6 is going to give us 12. 2 is the only number that could be divided by itself. However, 6 can also be divided in 2 other factors. For instance, 6 is a multiple of 2, and 6 is a multiple of 3 also. Now, we got it here. 2, we cannot divide it by anything else, by 2, and 2 also by 2, and 3 by 3, and that's what we finished. We found all the prime factors. So what happens when we find these factors? We multiply 2 times 2 is 4, and 4 times 3 is 12. So 12 is going to give us the same factor that we found. Of course, there are not only one way to describe 3 factors. If we decided to use 6 times 2 equals 12, we can also use another factor, which will be 4 times 3, which is going to give us 12 also. And let's see what's going to happen. If we have 4 as a factor, we know that 4 could be divided in 2 times 2. However, 3 is going to get 3 only. And if we find the same factors here, the answer will also be the same. Like this, 2 times 2 is 4, 4 times 3 is 12. So factoring 3 is a process of finding all the factors that we need to do. That's very important to remember all the divisibility tests and divisibility rules. All right, we can see the factors that give us 42. 42 is a number that if it's divided by 2 is going to give us 21, because half of 4 is 2, half of 2 is 1. If 2 times 21 is going to give us 42, still we have 21 as a factor. And if we can see in a multiplication table, 21 is also a factor in which if you multiply 3 times 7 is going to give you 21. In that case, we divide 21 in the factor of 3 and 7. But 3 is going to be a prime number because there's no other number that we can divide it evenly with 3. And the same thing with 7. So we finally did our factorization, and we're going to have to multiply. 2 times 3 is 6, and 6 times 7 is going to give us 42 when we found our prime factorization. Okay, once we know how to find the prime factors given the three methods, what's important to know is how to find the GCF. The GCF means the greatest common factor, and also the lowest common multiple. These numbers are very important depending on the operation you have to do. For instance, for solving fractions which have not a common denominator, we're going to need to use the least common multiple or least common denominator. So this is the way we can find the GCF and LCM. Let's see, for instance, have you used prime factorization to find it? Well, we did. Let's see how we can do it. The GCF is the greatest common factor. It is the largest value that divides exactly into 2 or more numbers. Let's explore it using a problem like you will see in school. Let's find the LCM and the GCF of these two numbers, 36 and 44. And we can also see that these numbers have to be found their prime factors by using the factor tree. As you can see, we can find the factors here: 3, 12, 3 times 4 is 12, 4 multiplied by 2 times 2 gives us 4. So the prime factors of 36 are 3, 3, 2, and 2, which are shown in this table. Now let's clear it up and find the same prime factors for 44. And we can see it: 4 times 2 times 2, and 11, which is a prime factor. So 44 is going to be divided into its prime factors, 2 times. But remember that should follow the same column of the prime factors. So now let's find which one is going to be the LCM. That means the least common factor. And the least common factors are going to be 2 times 2 times 3 times 3 times 11, which is going to be multiplied as follows. 2 times 2 is 4, 4 times 3 is 12, and 36, and we have to multiply by 11. So we get 36 times 10, it's 360, but since it's 11, we have to add 36. So finally, the LCM becomes 396, is the LCM. But what happens with the GCF, the greatest common factor? Well, let's see what's the common factor for these two numbers. The common factors of these two numbers are only these two. 2 and 2, which means that the greatest common factor that we can find for both numbers are 2 times 2, which, if you multiply, is going to give you 4. So you find that the greatest common factors is 4 and the LCM is 396. It is very easy to do it. So use the prime factors table. It will help you to organize your workspace. it's going to be very clear, at least likely to make mistakes. One last point. Before you have a go at GCF by yourself, you have to try this one. What happens if you have numbers like this? 10 and 21. As you can see, the prime factors for 10 is 2 and 5, and for 25, 3 and 7. So how do we get the GCF? So there's no common factors in this case. But then the only GCF possible is 1, because 1 in every number is always a factor. That's why it's very important to know what the GCF is. Well, thank you very much. That's all for factorization. I hope you liked it, and God bless you.